Hello, welcome back to LK Tuition. My name's Lucas and today we're going to be looking at the equations of parallel lines. Hope you're good and let's get started. Okay, so first of all, just a reminder of the equation of a line. So every straight line can be written in the form y equals mx plus c, where m is the gradient, so how steep the line is, and c is the y-intercept, where the line crosses the y-axis. Now, two lines are said to be parallel if their gradients are the same. So if they've both got the same m, then they are parallel lines and they're going in the same direction. Okay, so feel free to pause the video, have a go at these, otherwise we shall do them together. So number one says, write an equation of a line parallel to y equals 9x plus 7. Okay. Well, if they're parallel, the gradient just needs to be the same. So the gradient here is 9, so we just need any line that has gradient 9. So why not have y equals 9x minus 4? Could be anything. Yeah, so as long as that is 9 before the x, the y-intercept can be anything. Minus 4, plus 1,000,000, minus 50, can be whatever you like. Okay. Number two, write an equation of a line parallel to y plus 4x minus 6 is 0. So we just need to rearrange this a bit to make it into the form that we like, which is y equals mx plus c. We want y on its own, so we're going to get rid of these two. So we've got a plus 4x, so we'll minus 4x, and we've got a minus 6, so we'll plus 6. So rearranging this will give us y equals minus 4x plus 6. And we just want a line parallel to that. So let me just box off these answers. So a line parallel to this, it just needs a minus 4 in front of the x. So let's have y equals minus 4x plus 7. Oops, there we go. Alright then, so number three, write an equation of the line parallel to y equals x minus 2 that passes through the point 0, 10. Okay, so this isn't saying any line parallel to y equals x minus 2, it's saying this specific line. So if we know it's parallel, we know the gradient's going to be 1, so our answer is going to look like y equals x and something else. So let's leave a gap for that something else. Now, actually, the point they've given us is a really handy one because when x is 0, that is the y-axis. So that's telling you, just from that point, that the y-intercept is 10. So if you ever get a point that's 0 and something, that is giving you the y-intercept. But let's imagine it's not. Let's try something else. So we know it's y equals x plus something. Now if x is 0, y is 0, isn't it? So 0 equals 0. Now, how are we going to get to 10? Well, you'd add 10 from 0, wouldn't you? And that's where this 10 comes from. Okay, all right, and then finally, question 4, we want an equation of the line parallel to 6x plus 3y equals 12 that passes through the point 3, 8. So again, let's just rearrange this equation. So we want y equals something. So first of all, let's just take away this 6x. So we're going to be left with 3y equals minus 6x plus 12. So I've just taken away 6x from both sides. Then we want to get y on its own, so we want to divide everything by 3. So we'll end up with y on the left-hand side. Minus 6 divided by 3 is minus 2, so minus 2x, and 12 divided by 3 is 4. So the gradient of this line then is minus 2. So we want a line that's got that same gradient but passes through 3 and 8. So y equals minus 2x, and again we'll leave a gap. Now when x is 3, what are we going to end up with? So minus 2 lots of 3 is minus 6, and y is 8. So 8 equals minus 6. How would you get from minus 6 to 8? Well, you'd have to add 14. Yeah, so if you're at minus 6, you add 6 to get to 0, and then another 8 to get to 8. And that'll give you that line. Okay, let's have a look at one final question then, a little bit different. So this just says, here are the equations of 5 straight lines. write down the two lines that are parallel. Okay, well, we want to get them all in this form, y equals mx plus c, so we can work out the gradient easily. Now, this first one is great, that's already in the form. And before x, we've got 2, so the gradient of that is 2. If we look at the second one, we've got 2y equals x plus 3, so we want to divide everything by 2. So we're going to end up with y equals half of x plus 3 over 2. So the gradient of this is whatever's in front of x, which is half. Okay, so remember we're looking for two lines that are parallel, so we want two lines that match the gradient. All right, next one, we've got 4y equals 3x minus 2. So we'll divide this by 4, so we'll end up with y equals 3 over 4x minus 2 over 4, which is the same as 1 over 2. So the gradient of this one is 3 over 4. So we've still not quite had a match yet, so we'll keep going. Now the next one then, we've got 2y, so we'll divide by 2. So y is going to be equal to 4 divided by 2 is 2, so that's 2x minus 1 divided by 2, which is half. And the gradient of this is 2. Now here, I'm thinking I've got a match. Yeah, so I've got 2 there and I've got 2 there. So the two lines that are parallel are going to be line A and line D. And let's just double check the last one just in case we get something else. So here we've got 3y equals 2x minus 2, so let's divide by 3. And we end up with y equals 2 over 3x minus 2 over 3. So the gradient of this is 2 over 3. So that's no good either. So it's lines A and line D. Okay, so I hope you found that useful. This has been LK Tuition. Don't forget to like and subscribe, and I'll see you soon for some more maths videos.